Thank you all so much for being here today. Really excited to talk to you about plastic. So EsterCycle, what is it and who are we? Like he said, my name is Dr. Julia Curley, PhD in chemistry, official nerd. I am a researcher at the National Renewable Energy Lab and one of the inventors behind EsterCycle and will be the founder when we incorporate later this summer. Jason DeVoe is our techno-economic analysis and life cycle assessment guru, done some amazing analysis showing how our process for recycling could work at scale. And Dr. Kat Knauer is our fearless leader, advisor with over a decade of experience in polymer science, research, development, industry, and startups. As I said, we're spinning out our technology from the National Renewable Energy Lab, where it has been a project funded entirely by Amazon for our research and development. And they've been very generous in their support thus far as we now sort of start to take our own first few steps on our own. So the motivation behind EsterCycle really comes from the linear economy. The linear economy refers to the way materials currently move through our use and disposal. So right now, the majority of all plastics used every day come from fossil fuel-based sources. They have these really strong carbon-carbon bonds that hold them together and make them great materials, but hard to recycle. And so the fact that 50% of plastics that are used every day are used only a single time before they end up in the landfill or leaching into the environment is resulting in an ecological disaster that many are aware of. And so the future that we see with EsterCycle is circular. In a circular economy, materials will be sourced from biological sources. These materials called polyesters can be made biologically. They can replace all of the current plastics on the market today. And then after their disposal, they can be composted or degrade in the natural environment as a backup plan. But in order to keep that material in the supply chain and reduce emissions, EsterCycle is a method of recycling those materials back into the supply chain and heading towards a net zero plastics economy. So the EsterCycle process starts with a mixture of these materials, like I said, polyester that can be used in films, plastic bags, compostable cups, bottles, and we react them at high temperatures with an alcohol solvent that's present in your antifreeze in your car and our simple catalyst that breaks the chemical bonds that hold these plastics together and generate a soup of the building blocks that make up the plastics. Our next step in the process involves purifying and separating each of those building blocks so they can be remade into new plastics and sold back to manufacturers who want to make products with post-consumer materials. When we compare EsterCycle across various different ways to recycle plastics that are already on the market, mechanical recycling is how most of our plastics are recycled today, and that's a really, really great low energy process. However, it only works for a very limited, highly pure set of feedstocks. Pyrolysis is a different type of process that involves heating up plastics at really high temperature, and it can work for mixed feedstocks, but it's energy intensive and results in a kind of deterioration of properties down to fuels. Other types of chemical recycling similar to EsterCycle are being scaled and commercialized today. However, they all focus on single feedstocks, one type of polymer, and we really see the future of plastics. We need lots of different materials for lots of different applications, and EsterCycle aims to handle all of those materials in one pot. As I said, Jason's done some amazing analysis looking at the economics and the emissions of EsterCycle at full scale, showing it will result in a 31% reduction in price and a 46% reduction in greenhouse gas emissions for the recycled plastics when compared to making new materials. And so the market for plastics is huge. I'm sure all of you are probably holding plastics right now. I don't need to argue that. But what we're really excited about is the small market for bioplastics right now that is anticipated to grow rapidly in the next few years, and EsterCycle would like to grow with that market. We're looking at sourcing our materials from materials recovery facilities using advanced AI sortation techniques that are already being implemented, or from composters who don't want these materials in their feeds using depackaging technologies. Our commercialization plan, right now, we are in the process of raising non-dilutive funding through grants and fellowships in a total of roughly $7 million raise to build a 1 metric ton per day pilot plant right here in Colorado to divert plastic waste and start selling those materials back into the supply chain. After that, we're looking for full commercial implementation using dilutive funding to reach scales of 300 tons per day of material diverted in the next 20 years. So with that, I'd like to thank you so much all for your attention once again, and I'm excited to take any questions.